Yes, this is 1.5, solving inequalities. So far we have talked we are in unit 1. I think this is the second to last lesson in unit 1. So far we have done linear equations. There's one solution and the graph is a straight line. Quadratic equations, the graph is a curve and there are 2, 1, or 0 answers. And we practiced how to find the answers for quadratic equations. Quadratic equations, the most used ones are factoring and the quadratic formula. Linear equations, we're trying to isolate x by doing the inverse of multiplication, the inverse of division, and addition and subtraction. I repeated one of those. And then we did radical equations. So the inverse of a radical would be a power. And so we worked on how to go from a power to how to get rid of a power or how to get rid of a radical. Okay, that one we had to find solutions and then make sure the solutions were not extraneous. And then if you had a negative under the radical, we used the imaginary unit and we used complex number systems to get an answer that worked so that we could keep working on the problem. Okay, so now this is a pretty big change, not really related to that. We are doing inequalities. So an equation has an equal sign, an inequality does not have an equal sign. It has something instead of an equal sign. Okay, so so you have seen inequalities, right? A new way to write inequalities is interval notation. And then we're also going to practice how to graph an inequality. Okay. It's good if you are able to read an inequality, like from left to right. So we always read this way. And for example, this inequality would be x is greater than or equal to a, x is greater than a, x is less than or equal to a, x is less than a. Okay, these we call compound inequalities. Just like a compound word is two smaller words put together, a compound inequality will be two inequalities with the word and. So this could be written as a is less than x and x is less than b. Or, so you could separate them and put the word and have a space there. Or you could just say a is less than x and x is less than b. A is less than or equal to x and x is less than or equal to b. Okay, and you can mix them up too. A is less than or equal to x, x is less than b. A is less than x, x is less than or equal to b. Okay. So we're thinking about, when we're graphing, we're thinking about a number line. And if you're talking about greater, you're always talking about this direction. So greater is always to the right. Lesser is to the left. When you're graphing, okay? When you were graphing, you possibly used something like an open circle to say this does not include, right? does not include the number. Or you could use a closed circle to say does include. But in Pearson's and in this course, instead of a closed circle, we use a bracket to say it does include. So our graph will instead look like this, okay? And for an open circle, we're going to use parentheses. And then the arrow, okay? So where you used to see a closed circle or an open circle, you will now see a bracket or parentheses, okay? So, and let's just explain that a little bit more. So right down here, I will say these two symbols means it does not include the number, right? Like if I was to say X is less than 5, it does not include 5. X is greater than 5, it does not include 5. Okay? So does not include, we're going to use these symbols, just the parentheses. All right, so either of these would be does not include. And then includes would be less than or equal to. So it does include that number. I just wrote the same symbol again. Okay, so X is greater than or equal to -5. So it does include 5. X is less than or equal to 5. So it does include 5 when we're graphing it. Okay. So this also follows interval notation. So if I'm graphing this, X is greater than -5, X is smaller than 5. My graph will actually be, if this is -5 and this is 5, my graph will look just like that. Okay. And it's the same graph because these are the same symbols, same numbers, except now I have or equal to. So now my graph is going to have brackets. So this is how I would graph this inequality. This is how I would graph this inequality, this compound inequality. And then in interval notation follows the parentheses or the brackets. So interval notation up here uses the same brackets that graphing uses. So if it includes A, we use a bracket. If it does not include A, we use a parenthesis. Does not include, so X is greater than -5. So we put a regular parenthesis, -5, +5, close parenthesis. Does include, so we're going to use brackets instead of parentheses. Okay. Interval means part. So interval notation is describing to me what part of the number line I'm talking about, right? I'm talking about the number line between -5 and 5. I'm talking about the number line between -5 and 5 again. Okay, but this time it's including 5. All right, where shading starts to where the shading ends. And again, we read it from left to right. So let me give you another example. Another example might be X is less than 3. All right, there, that is the inequality. The graph will look like this. Let's put 3. X is less than 3. So my arrow, it's every number less than 3. My arrow is going to go that way. It does not include 3. So it will not be a bracket, it'll be a parentheses. Remember, this is includes, does not include. And our interval notation for that is parentheses, just like that, parentheses. So it ends at 3. It does not go past 3. It does not include 3, but it goes forever this way. What's a symbol for forever? Infinity. And because it's forever, to the left, where everything is less, we say negative infinity. Okay? Negative infinity always gets a parenthesis because there is no final number to include. It goes forever, so there's no including the last number of negative infinity. There's no including the last number of infinity. So here is the inequality. Here is the graph, and here's the interval notation of x, every number less than 3. Okay. Over here, I'll do x is every number greater than or equal to 4. Keep it simple, right? Make it so you can see these other examples at the same time. X is less than, or sorry, greater than or equal to 4. How do I graph that? I draw a number line, I put a 4 on that number line, greater than 4. Greater than 4 means my arrow is going to go towards 5, right? It includes 4, so I need the bracket. And just like this was negative infinity to 3, now we're going to start at 4, but include 4 and go to infinity. Infinity is forever, but it gets a parentheses. It does not get a bracket. Okay. So now you know 3 ways to talk about inequalities. All right. And just to be clear, the compound inequality is 2 in 1. Let's make one up. Compound. -3 is less than x is less than or equal to 5. So we have -3 is less than x is an inequality. X is less than or equal to 5 is another inequality, right? All the values that x represents are between a -3 and a 5. Every value that x represents is between a -3 and a 5. Oops. 5. That was supposed to be a line. So x is greater than 3. X is less than or equal to 5. So that one includes 5, but it does not include 3. And we make a line. Parenthesis, -3, comma, 5, closed bracket, because the closed bracket includes the number 5. Oops, you couldn't see that part. I apologize. So it was parenthesis, -3, comma, 5 with a bracket. The bracket because it includes the number 5, the parenthesis because it does not include the -3. All right, so we have inequalities. We have 2 compound inequalities and we have 2 inequalities. We are going to use interval notation and then we are going to use graphs to represent these inequalities. You have the inequality. We're going to write the interval notation and we're going to write the graph. Okay. 4 is less than or equal to x, and x is less than or equal to 7. Interval notation, it includes the 4, so that's a bracket. It includes the 7, so that's a bracket, right? X is greater than 4, so 4 is my first number. 4 is the smallest number it could be. X is less than or equal to 7, so 7 is the biggest number it could be. That is the interval notation for this compound inequality. To graph it, I'm going to put a number line with a 4 and a 7. I know it includes 4. And I know it includes 7. I know x is bigger than 4, so I know it goes this way from 4. And I know x is smaller than 7. So it goes that way from 7. It includes everything between 4 and 7. There's your interval notation, and there is your graph. Here, x is greater than -3. It does not include -3, so it's a parenthesis. And x is smaller than 0. It does not include 0. Just like I have parentheses here, because it does not include, I'm going to put parentheses on my graph because it does not include those numbers. All right. For these, it's a little bit easier for me to draw the graph first. So I'm going to draw a graph with a 3 on it. This says x, remember we always read from left to right. So it says x is greater than 3. X is greater than 3 means x is over here, right? 4 is greater than 3, 5 is greater than 3, 6 is greater than 3. It does not include 3, so I'm going to use my parentheses. Now I see the parenthesis is going this way, so 3 is my first number. 3 is the smallest number it can be, and it goes on forever. Forever is infinity. X is less than or equal to 5, so I'm going to make a graph with the number 5. X is less than 5, just like 4 is less than 5, 3 is less than 5, 2 is less than 5. And it could be equal to 5, so that includes. My first number is not 5, right? 5 is going to be my last number, and it includes it, so I'm going to use that same symbol. And it starts an infinite distance away, so negative infinity. We have just used interval notation and graph to represent these 4 inequalities. Write as an inequality involving x, and then write as a graph. So same thing, they give us the interval notation, we make it into a graph, okay? So this graph will have what 2 numbers on it? The number 0 and the number 3, right? If I see a bracket, I'm going to graph it with a bracket. And then here I see a parenthesis. The bracket means includes, right? So if I have a bracket, I'm going to say it is greater than or equal to. If the bracket's going this way, I'm going to say it's less than or equal to, right? If the bracket's going this way, it's greater than, or sorry, the parentheses is going this way, it's greater than. If the parentheses is going this way, it's less than, right? Brackets includes parenthesis does not include. Right? These include the number. These do not include the number. Just so that I can remember, okay? So if I see this and the arrow is going this way, 0, what's over here? Is this 1 or -1? This is 1, so it's greater than, right? Greater than. X is greater than or equal to 0, right? And this one, X is less than, right? X is less than 3. It does not include 3. It might be easier though, for you to just say 0's first, right? Three seconds. So you can either write it as 2, or I write it as a compound inequality. It starts at 0, it includes 0, ends at 3, does not include 3. Okay, so you could think about it, X is greater than 0, or you could say it starts at 0, 0 is smaller than or equal to X. Next one. We have the number 3, and we have infinity. It's a positive infinity, right? Positive is always this way, right? This is positive or greater. This is negative and less. So if it's a positive infinity, my arrow is going this way. And it does not include, right? So here, X is greater than 3. Because over here is going to be 4, right? 4 is greater than 3, but it does not include 3. It does not include 3. All right, between 3 and 4. Between 3 and 4. You could either make a compound inequality or think about what X is for each one. A bracket like this, a bracket like this, connect them, right? So it's either 3, including 3, and then 4, including 4, or I can say 3 is, X is greater than 3, right? Over here, 4 is greater than 3. X is greater than or equal to 3, and X is that way. Smaller than, less than, or equal to 4. Okay. Last one. -5 and negative infinity, including -5. And it's going this way, right? Negative infinity goes towards less. It's a bracket, right? So X is something and equal to because of the bracket, right? X is greater than or equal to -5, or X is less than or equal to -5. X is less than or equal to -5. Because it's going that way. Towards negative infinity. All right, now we're going to work on solving inequalities. 1 minute. Solving inequalities using the same skills, or you could say the same rules, we use to solve equations, with one exception, okay? Anytime you multiply or divide by a negative number, flip the inequality symbol so that the statement stays true, okay? So, just gonna add a note. If you multiply or divide by a negative number, flip the inequality symbol to keep the statement true. So if I have the number, let's say 8, 8 is less than 12, right? What if I multiply both sides by 2? Two times 8 is less than 2 times 12, right? That becomes 16 is less than 24. That's still true, right? What if I divide? New color. 8 divided by 4 is less than 12 divided by 4. 8 divided by 4 is 2, is less than 3. Still true, right? That one's okay. What if I use a negative 2? Negative 2. Negative 2 times 8 is less than negative 2 times 12. Now it's negative 16 is less than negative 24. Is that true? That is not true unless we flip the sign. So it's only true if we flip the sign. Anytime you are multiplying by a negative, you need to flip your sign. Negative 2 on both sides, so the sign gets flipped. And same with division. Same with division. 8 divided by negative 4 will give me negative 2, right? 12 divided by negative 4 will give me negative 3. And I can't keep the sign the same. I have to flip the sign. Okay? So you always want to flip the sign. Positive, it's okay. Positive, it's okay. It stays the same. But if your sign that you are dividing by is negative, flip the sign. Flip the symbol. Flip the inequality symbol to keep the statement true. That is the only difference between equations and inequalities. All right, so we're just going to look at it the same way we would look at it if it was an equation. 3x is less than 12, or what can I multiply by 3? What are all the numbers I can multiply by 3 and still get a number less than 12, right? I want to isolate x, so I'm going to divide by 3. 3 divided by 3 just leaves me with x. 12 divided by 3 is 4. So x is less than 4. X divided by negative 2 is greater than 6. I want x alone. It's being divided by negative 2, so I want to multiply it by the least common denominator. The least common denominator will be negative 2. Multiply everything by negative 2, so that means flip the sign, right? Very important to flip the sign because of those negative signs. Negative 2 divided by negative 2 just leaves me with x. 6 times -2, -12. X is less than -12. -5x is less than -10. Divide by -5 on both sides. Flip the sign because it's a negative. -5 divided by -5 leaves me with x. -10 divided by -5 leaves me with a +2. So even though my answer doesn't have any negatives, I still had to flip the sign to keep it true. -x is greater than 7. That's kind of like saying -1x is greater than 7, right? I can't see the 1, but it's a -1x. So I divide by -1 on both sides. If I divide by -1, I need to flip my sign. -1 divided by -1 gives me a +x. 7 divided by -1 gives me a -7. X is less than -7. Solve, write your answer using interval notation and graphs. Sorry, I skipped all of that part. Now that I look at it. All right, so my answer is X is less than 4. The graph of X is less than 4. It's gonna look like this, right? Everything less than 4. So that means it starts at -infinity, goes to 4, but does not include 4. Does not include 4. X is less than -12. By -12 on my number line. X is less than -12. It does not include -12, and it is smaller. So it starts at -infinity, goes to -12, does not include -12. X is greater than 2. Here's 2. Every number bigger or greater than 2 will be that way. So my interval notation will start at 2 and go forever. Infinity never gets a bracket. It always gets a parenthesis. X is less than -7. So I'll graph -7. X is less than -7. Does not include. So my graph, sorry. My graph starts at -infinity and goes to -7. Does not include it. Sorry if you couldn't see that one. My graph starts at 2, but does not include it and goes till infinity. Infinity always gets a parenthesis. Okay, example 4. Solve, writing your answer using interval notation and graph. Okay, so for this one, it would be all values I can multiply by -4 and combine with 5 to get a number less than 9. The first thing I want to do is isolate the letter X. Okay, so to isolate X here, I'm going to subtract 5. -4x is less than 9 minus 5 is 4, right? Now I'm going to divide. I'm going to write this all down here. I'm going to run out of space immediately. All right, so number 1 was 5 minus 4x is less than 9. We took away 5. We got -4x is less than 4. Now I need to continue isolating x divide by -4 on both sides. Since I divided, I'm flipping the sign because of the division by a negative. -4 divided by -4 just gives us x. 4 divided by -4 gives us -1. X is greater than -1. And it says, write your answer using interval notation and a graph. Here is -1. X is greater than -1, but does not include it. That way. So I know my interval notation will start at -1 and it goes to infinity. All right, number 2. 2x minus 2 is greater than or equal to 3 plus x. Here, I want to isolate, but I need all my x's on one side, right? So let's subtract x. Subtract x. 2x minus x is just x. The -2 and the 3 stay the same. X minus x is canceled out. Now I'm going to move the 2 over by adding 2. X, those cancel out. Greater than or equal to 3 plus 2 is 5. How would I graph that? Start with 5. It's greater than or equal to, so it does include, and greater than would be towards 6, right? So just like this starts with a bracket for including 5, our interval notation starts with a bracket and goes to infinity. Infinity always gets a parenthesis. Okay. Example 5. All right, so this one looks like 4 is less than 2x plus 2, which is less than 10. We want to isolate the x in the middle, right? And I have 3 sides of the equation. I have the left side, the middle, and the right side. So anything I do in the middle, I need to do to all 3 sides instead of 2. All right, so I'll subtract 2, subtract 2, subtract 2. 4 minus 2 is 2, is less than 2x, is less than 8, right? Now I'm going to divide by 2. 2 divided by 2 is 1, is less than x, is less than 4, right? So my graph will start at 1 and end at 4, and it will not include either 1 or 4. Okay, and just like my graph used parentheses, my interval notation will use parentheses. Parentheses 1, comma 4. Close the parenthesis because it does not include. And our last one. All right. I had to pause the video, but I'm back. And I think I'm going to do number 4 on the back. So number 4 is 1 is less than or equal to 2 minus x over 2, which is less than or equal to 4, right? So we need to isolate x in the middle, but x is part of a fraction, or there's a fraction in this inequality. So the first thing we want to do is find the least common denominator. Denominator is the bottom of the fraction. So there's only one denominator, it's 2. So find the LCD. The LCD is the number 2, okay? Then we multiply everything by the least common denominator. So on this side, means we multiply 1 times 2. We multiply all of this by 2. And then we multiply 4 by 2. 2 times 1 is 2. The signs stay the same. 2 minus x divided by 2 times 2. The reason we did that was to cancel out this 2 and this 2. So now it's just 2 minus x less than or equal to 4 times 2 is 8. Right? Now we want to isolate the x in the middle. All right, so if you ever have an x over here and an x over here, put them both in the middle. To do that, we would subtract 2. Remember, we have 3 sides now instead of just 2. So subtract 2, subtract 2, subtract 2. 2 minus 2 is 0. This is a negative x. 8 minus 2 is 6. All right, so to get rid of the negative x, it's a known 1, right? So the negative sign is also a negative 1, negative 1x. So I'm going to divide x by negative 1. Anything I do to x, I have to do to everything else. So negative 1 on all 3 sides. 0 divided by negative 1 remains 0. Negative x divided by negative 1 becomes a positive x. And 6 divided by negative 1 becomes a negative 6. So I just switched all of their signs so that I could have a positive x. But I divided by a negative. So that means I need to switch my signs, right? When I divide by a negative, I switch my signs. And because we've only ever seen the less than sign with the x in the middle, we have to remember that now it says 0 is greater than or equal to x, and x is greater than or equal to negative 6. Okay? So if you wanted to, you could rewrite that as x. So we know x is greater than or equal to negative 6. And x is, if I read it backwards, right? X is less than or equal to 0. Right? So you can look at it like this, or you can look at it like this, so that the variable is always on the left, because that's always easier for me. So when I graph this, x is, oh, I needed, sorry, negative 6 over here, 0 over here, right? Because this way is always lesser, this way is greater. So when I graph it, x is less than or equal to 0. X is greater than or equal to negative 6. Only these numbers. Okay? So make sure that you just kind of like read it out loud to yourself. 0 is greater than or equal to x. X is greater than or equal to negative 6. So it needs to go this way. Or if you want, you can flip the whole thing around. So you're always reading x is. And it will always tell you which way to draw your arrow, right? If the variable is always on the left, this will tell you which way to draw your arrow. X is less than, I'm going to draw my arrow this way. X is greater than, I'm going to draw my arrow this way. All right, and that is it for 1.5. Thank you guys.